First law of motion, the law of inertia. An object will remain at rest unless acted upon by a force. An example of this is moving a chair which is at rest.
Good day everyone, I'm Jahu Ranion. Newton's first law of motion is an object at rest and an object in motion continues in motion unless acted on by a net force. So here's an example. When an object is at rest, it will remain at rest unless acted on by an unbalanced force. Now the object in motion will continue with a constant speed and direction, or it is called velocity. It won't stop unless acted on by an unbalanced force. So Mr. Navales will now show us the practical examples about the Newton's first law of motion.
Hi, I am Alper Navales, and now I am going to give two practical examples about Newton's first law.
Now, the first example is when you ride a vehicle. Your body stays at rest, but when a sudden force were applied, like a sudden stop or brake, our bodies will go forward instead of stopping with the vehicle, because the inertia keeps us moving forward. But in order for us to change our motion, a force is required, such as the pull of a seat belt in most vehicles. To make it clear, let us use the most common example of inertia. When the card is pulled, the coin falls into the glass instead of going with the card. This is because inertia of the coin maintains its state at rest and falls into the glass due to gravity.
Now I show you the example of Newton's second law. But first, Newton's second law is, if the same force is applied to an object with greater mass, the object accelerates at a slower rate because mass adds inertia. When I push this chair with a light thing above on it represent as mass, the speed increase with a high acceleration. This time, when I push this chair with this heavy thing above it represent as more mass, the speed increase is slower and has a less acceleration. It is because mass adds inertia.
Newton's second law of motion says that acceleration happens when a force acts on a mass or an object. Riding your bicycle is a good example of this law of motion at work. Your bicycle is the mass, and your legs pushing the pedals is the force. When you push on the pedals, the bicycle accelerates. Newton's second law also says that the greater the mass of the object, the greater the amount of force needed to accelerate the object.
Moving on to the next, Newton's third law of motion, which is the law of action and reaction.
We might have noticed that the people tend to know the third law more than the rest of the laws because of its famous phrase, for every action, there is an equal and opposite reaction.
But scientifically, we can safely sure to say that forces come in pairs. Force is an interaction between two objects. This means that if object A pushes on object B, then object B pushes on A with the same force but in the opposite direction.
For example, when you place this pen organizer on the table, this is what happens. The pen organizer exerts a downward force on the table, which is counteracted by the table exerting an upward force on the pen organizer. The table's force and the force of the pen organizer are the outcomes of this interplay. Both forces have the same magnitude, yet their directions are opposite.
And as you sit in your chair right now, the force of the gravity is pulling you down towards the center of the earth, with something called the normal force points straight up with the same magnitude, which is why I remain perfectly sitting and watching the handsome guy on the monitor right now. Ho 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 ho!
Law of Universal Gravitation states that any particle of matter in the universe attracts any other with a force, varying directly as the product of the masses and inversely as the square the distance between them. So let me give you some example of this law. If I drop this pen towards the ground, is the same force that causes the moon to fall around or orbit in the earth. I will give you another example. I will compare these two objects that the one object has a 5 times mass than other object. What will happen if I drop these two objects and which object will hit the ground first? They hit the ground at the same time. Why is that? So the larger object has 5 times force than the small object, and that therefore resists the acceleration by a factor of 5 times. The result is the acceleration of the large object is not greater than a small object. It is exactly the same as the small object.